handle the uncertainties if you are adding those values or multiplying. So basically when you add both of those upper bounds, you get the upper bound, both of the lower bounds, you get the lower bound. For example, let's say we are talking about two different lengths, length of A and length of B. And let me say this is 7 centimeters and correct to plus minus 0.5, and the next one is 10 centimeters correct to 0.5. So upper bound definitely would be 7.5 plus 10.5. The longer lengths, this is 18. This is one way. The other way could be we can do 7 plus 10, the original length, and then use this formula that add those values. So 0.5 plus 0.5 is already 1. 10 plus 7 is 17. 17 plus 1 is 18. So either we remember this or we individually add the bounds to the values or subtract it from the values. And when there is a product, that means for example we are finding the area of a rectangle, then we'll multiply and we'll get the upper values or lower values. Same goes with subtraction and division. I personally prefer adding them individually. In that case I don't have to remember the formulas. The side of triangle are measured correct to the nearest centimeter. Write down the upper bound for the length of the three sides. Nearest centimeter. So we know this is plus minus 0.5. Any disagreement? So now it says the upper bounds. I know that it is 7. So upper bound would be 7.5. So what if I just write 7 plus 8 plus 10, and I know I have to write 0.5 3 times. So I can directly write 3 into 0.5. So 7 plus 8 is 15, 15 plus 10 is 25, 25 plus 1.5 is 26.5 centimeters, and we get the upper bound. Or we could have directly added 7.5, 8.5 and 10.5. B part is work out the maximum. Write down the upper bound for the length of the sides. Sorry, only the upper bounds. So that is 7.5, 8.5 and 10.5. B part says possible perimeter. So the maximum possible perimeter is 26.5. Number 2. The dimensions of the photo are measured correct to the nearest centimeter plus minus 0.5. Work out the minimum possible area. So minimum possible area, 5.5 multiplied by 8.5. We take the lower bounds and we multiply them. And I'm getting 46.75. This question is interesting. In this question, the value of A is either 4 or 5, and the value of B is either 1 or 2 exactly. Work out the maximum value of A plus B. Give me your final answer. Ali, what about you? 7. Yes, R is 7. Maximum possible is 5 plus 2. That is 7. And minimum possible value is 5, right? Maximum value of the product A into B. That's right, 5 2 times is 10. And A minus B maximum value. 4 maximum. So we take maximum of A and minimum of B. Then minimum value of A minus B. Maximum value of A divided by B. So we take the numerator, larger number, and denominator, the smaller number, to get the overall greater value. G part, the maximum value of A divided by B. Aren't these both same? Max, oh, minimum. I read maximum. So minimum is value of A should be small and B greater to yes. Maximum value of A square minus B square. Very good. 25 minus 1 is 24. Question number 4. If P is equals to 7 centimeters and Q is equals to 5 centimeters, both to the nearest centimeter. So nearest centimeter we know plus minus 0.5. So I'm writing those values for myself. 6.5 and 7.5. On the other side, 4.5 and 5.5. Find the largest possible value of P plus Q. Yes, that is it. 13. So 7.5 plus 5.5 is equals to 13. The smallest possible value of P plus Q. So we take both of the lower bounds and we get 11. Largest possible value of P minus Q. Aris, you're not participating. Aris, to get largest value, we need P upper bound and Q lower bound. So there is a greater difference. So upper bound of P is 7.5. That's right, Ali. And lower bound of Q is 4.5. So 3. Largest possible value of P square by Q. 7.5 square by 4.5. 12.5. If A is 3.1 and B is 7.3, correct to one decimal place. So one decimal place plus minus, what do we do? What do we add? What is the uncertainty? Plus minus 0. It says one decimal place. One decimal place means 0.1. So we always add half of it. So 0.05. Uncertainty is 0.05. So find the largest value. Now we choose these values. So A would be 3.15. B would be 7.35 because of this uncertainty. Uncertainty correct, you'll get the correct answer. B part, largest possible value of B minus A. What should I write for B? 7.35. And for A? A is 3.1. So what do we write, upper or lower bound? We have to get the largest value of A, B minus A. How will we get the greatest difference between B minus A? Great, it will be greater when value of B is larger and value of A is smaller. So there will be more gap between them. So I'm writing the upper bound of B and I'm writing the lower bound of A. Question number 6. If x is equals to 5 and y is equals to 7 to one significant figure, so what do we add and subtract? Plus minus what? 0 point what? 0.5, yes. It said one significant figure and we're looking at the values, they are one digit, one integer. So half of that is 0.5. So smallest possible value of x plus y, smallest value of x is smallest value of x. Smallest value of x, what should I write? No, Ali. Can you see this value x is equals to 5? So what is the smallest value of x? You know the uncertainty is 0.5, 4.5. So 4.5 is smallest value of x and what is the smallest of y? 6.5. So when you add these two, you get 11. B part, smallest value of y minus x. What should I write for y? 6.5, and in place of x, we will write 5.5. Why so? Don't get confused with this word. When it says smallest, so we're not selecting everything smallest. We need to know y minus x smallest. So y should be lesser value and x should be greater value to have lesser difference between them. So this gives me 1. And then for x over y, numerator should be smaller and denominator should be bigger to get a smaller value. This is 3 by 5, which is equal to 0.6. Number 7. In the diagram ABCD, the outer rectangle and EFGH inner rectangle are with sides AB is 10, BC is 7, EF is 7, FG is 4. All figures accurate and correct to nearest centimeter. So plus minus what? What do we add and subtract? Ali, you did question 10 and you got all of them correct. Nearest centimeter means plus minus half of that. So find the largest possible value of shaded area. So it would be largest when the outer is greatest and inner is least. So what values should I write for the outer area? Length into breadth minus length into breadth. Values for outer area. Ten 10.5 into 7.5. And values for inner triangle 6.5 into 3.5 because we need a larger difference. So I need this to be more and I need these second values to be less in order to create a larger difference. 10.5 into 7.5 minus 6.5 into 3.5 gives me 56 centimeter square. So this is the largest possible area for the shaded region. Question number 8. When a voltage V is applied to a resistance R, the power consumed is V square over R. If you measure voltage as 12.2 and resistance as 2.6, correct to one decimal place. What do we add and subtract? Very good. 0.05. It is already 1 dp, which means 0.1. Half of that is 0.05. Very good. So now the question says calculate the smallest possible value of P. V square over R. How do we get the small value of P? Numerator should be more or less? Less. So lesser value of 12.2 is when we subtract 0.05, we get 12.15. We'll come to that. And denominator should be greater in order to get overall lesser value. So I'm getting 55.706 approximately equal to 55.7. Next topic is estimation.